going to talk about what a general formula for a sequence looks like. General formula for a sequence. Here's just an example. Sometimes when they're writing out the formula for a sequence, they'll use these curly brackets. Okay? Suppose we have a problem that gives us this information, this formula, and says find the first 5 terms of the sequence. That would mean that we plug in n equals 1, n equals 2, n equals 3, n equals 4, n equals 5, and then that would give us the first 5 terms for this sequence. So you know how I said typically we're going to use A? We are. This one happens to use S. So just don't let it confuse you. So that's like S is the Y value, N is the X value, more or less. So we're talking domain, range, and we plug this number in, we get these numbers out, and our domain is always these natural numbers. Okay, so S sub 1, the first number in our sequence, we get by plugging this 1 in. So 1 squared plus 1. So that gives us a number of 2. The second number comes from going 2 squared plus 1. Again, we're just plugging the 2 in for n. So that's 5. The third number would be 3 squared plus 1, which would be 9 plus 1 is 10. The fourth number would be 4 squared plus 1, which of course is 17. And so then the fifth number would be 5 squared plus 1, which is 26. Okay, so the sequence that they wanted us to create begins with these 5 numbers, and if you kept plugging more numbers in, you would get the rest of the sequence, which presumably goes on forever. Okay, when a question says find the nth term, that is sequence ease, language in math language, asking you to find a general formula. Okay, for example, write a general formula would be one way of asking, and that's the obvious way. Or find the nth term of this sequence. 1, 1/2, 1/4, 1/8, etc. Okay, so we can see the pattern. Basically, each number is being halved to get the next one. How can that help us figure out what the next number will be? The question to ask yourself is, how can I get to the next number from the previous one? If each one's being halved, then if I take a number and I multiply it by a half, then that would give me the next number, correct? Another thing to look at is, since each is being halved, notice that these numbers on the bottom of each fraction end up being a power of 2. This is 2 to the first power, 2 to the second power, 2 to the third power. The next one would be 16, which would be 2 to the fourth power. So when you start recognizing things like that, you're able to start thinking about what's going to make that formula work. Okay, so if I'm trying to write a formula for this sequence, here is what will work for this one. And let me explain a little bit where it comes from, because I'm just going to give it to you, and I sort of started to explain it. But we need to start at the number 1. So, and we also need to be able to plug in n. N equals 1, n equals 2, n equals 3, n equals 4. So sometimes it helps to actually put your n values there and think, how do I get from this number 1 to that number 1? How do I get from that number 2 to that 1/2? How do I get from that number 3 to that 1/4? So we were just thinking about how this is 2 to the first power, 2 to the second power, 2 to the third power. The next one would be 2 to the fourth power. If you think about those powers, this one was 2 to the first power, that's 1 smaller than this number. This was 2 to the second power, that's 1 smaller than this number. 2 to the third power is 1 smaller than that number. So in order for us to be able to plug in these exact numbers and get those results, we have to actually tell our formula, in our formula say we're going to plug in n, but then we have to subtract 1 to get it to where we need it to be. So if we go 2 to the 1 minus 1, that's 2 to the 0 power. Well, anything to the 0 power is 1, and so 1 over 1 is 1, and that gives us our first number. Okay, so 1 half, we plug in a 2. 2 minus 1 is 1. 2 to the first power is 2, and so 1 over 2 is 1 half. Plug in a 3. 2 to the 3 minus 1 power is 2 to the second power, which is 4, so that's 1 over 4, or 1/4. And thus, this formula will give us each of the terms in the sequence if we plug in the term number for that term. So this is term 1, term 2, term 3, term 4, and then these are the actual terms of the sequence. And they also will keep going forever. Okay, maybe we should do one more of those. So here's another example. 2/3, 4/9, 8/27. This is kind of a similar idea, a little different though. Keep going. So again, if you look at n equals 1, 2, 3, 4, typically that helps you kind of figure out how to get from these numbers to those numbers. Okay, so then let's look at what's happening here. Well, notice how this number is a 1, we have a 2/3 fraction. This number is a 2. If we do 2 squared and 3 squared, using that 2, that would give us that number. Here's a 3, 8 cubed and 3 cubed, associated with that 3. This one would be like 2 to the 4th and 3 to the 4th. So this ends up being a fairly easy formula to write. That should be a sub n. Sorry about that. Or maybe I should use a, since I said earlier that we were going to use a for the y value, and then I keep using s. It doesn't really matter, they're all variables. Okay, so a sub n, our formula would be 2/3 to the nth power. So it's just that 2/3 just keeps getting multiplied again and again and again. And so we can just plug in these numbers, n equals 1, n equals 2, n equals 3, n equals 4, to get to that answer. Okay, those are general formulas. The other type of formula we have to deal with is called a recursive formula. Every sequence has a general formula and has a recursive formula. Okay, so a general formula is kind of nice because you just plug in whatever value of n you want and you get that number in the sequence. A recursive formula is dependent on having a previous term. So the sequence comes from plugging in previous numbers from the sequence into the formula. I found that sometimes students have a little bit of a hard time with this, not because it's hard, but because of the notation. Okay, let's do an example. Let's suppose that a sub 1, so that's our first term, equals 3. You have to have somewhere to start. And then all of the terms after that, a sub n, come from this recursive formula, 4 minus a sub n minus 1. Now remember what I was saying earlier about this is an index. This does not mean that that's actually part of the problem, to subtract 1. This is telling us which a value we are looking at and plugging in here. This is a variable that keeps changing as we go up through the sequence. Okay, so let's plug this in. So they give us a starting number. So if we want to find the next one, this says to find a sub n, or a sub 2 in this case, we need to take the number 4 and subtract a sub 2 minus 1, because we're doing a sub 2, so that's a 2. So 2 minus 1 is 1. So we're subtracting a sub 1. So a sub 1 in this case is 3. So we get an answer, 1. So there's the next number in our sequence. Is that confusing enough for you? So a sub 3, we go back to our recursive formula, which is 4 minus, in this case it would be a sub 3 minus 1, which is a sub 2. So a sub 2 we just barely found. It's 1. So we subtract 1, and we get 3. A sub 4 is going to take that answer and subtract it from 4 and get 1. What's going to happen with this pattern? Very interesting pattern because it's just going to keep going back and forth. So this particular sequence is 3, 1, 3, 1, 3, 1, etc. Okay, let's do another one of those. Let's say a sub 1 is negative 2, and a sub n is n plus 3a n minus 1. Now this one's kind of strange, because not only do we use a previous number from the sequence, we always also use the number for that sequence item. So which item it is, which number it is in the sequence. We're using the actual n in the formula, which is a little bit strange. Okay, so to find a sub 2, we're plugging in the number 2 plus 3 times the previous number. Okay, so we work that out and we get 2 minus 6, so negative 4. So a sub 3 is the third number, so our formula says we use a 3 because it's the third number, plus 3 times the previous number. So 3 minus 12, negative 9. So a sub 4 is the fourth number, so we plug in a 4 for the n, plus 3 times the previous number, which is a negative 9. So that's a negative 27 plus 4, so negative 23. So you can see our sequence building negative 2, negative 4, negative 9, negative 23, and it will keep going on using this pattern.